Okay, good morning, everybody, and welcome to our March Data Science Education webinar of 2018. This webinar is being made available through the Concord Consortium, a nonprofit educational technology laboratory based in Concord, Massachusetts, and also in Emeryville, California. That's where I am. You can learn more at our website, concord.org/meetup. I'd like to introduce you to today's joint facilitators. We have Stephen McGee and Noelia Baez Rodriguez. Stephen and Noelia will be speaking about this NSF project they've been collaborating on, Data Jam. The Data Jam model is to support students in addressing their own research questions by exploring, analyzing, and summarizing long-term data about the environment and then creatively communicating their discoveries to non-scientific audiences. A recorded version of this webinar will be made available on YouTube. We will email you details about it through Eventbrite after the event. If you are comfortable sharing your name and face, please turn on your web camera during the webinar event so that we can see you. I'd also like to emphasize that the format of this webinar is participatory by design. This means that we will work together to decide on the conversations, connections, and activities that we want to discuss today. Phil and I will be facilitating the live questions that you have, and I will be managing the text-based questions both on Zoom chat or Google Docs, wherever you're comfortable. Stephen and Noelia will explain what that means in just a few seconds, the participatory by design format. For those of you just joining us, welcome to our webinar. Our speakers are Stephen McGee and Noelia Baez Rodriguez, who will be speaking about the Data Jam project. Stephen and Noelia, I'll let you take it from here.
Okay. Okay, so now I can request to share my screen. All right.
Noelia, you mentioned a Google Doc. How do we get access to that?
I will share a link in the chat.
Thank you.
Yeah, we'll have a couple of links that we'll share later on for the participatory part. So thanks, Natalia, for the introduction. So what we're going to do today is we'll start with a little bit of an overview of the Schoolyard program down in Puerto Rico, and then we'll have an opportunity to actually engage with the data that we use for the Data Jam, using the wonderful tool that Concord has developed called CODAP, which I understand many of you who are regulars in this series are quite familiar with. So the Schoolyard, well, I guess actually we'll talk more about it, but we're part of a program called the Long-Term Ecological Research Program, which is a National Science Foundation funded initiative that's, I think, coming up on 40 years that some of the sites have been involved. Our particular site, the Luquillo Long-Term Ecological Research Program, is located in the Caribbean National Forest in Puerto Rico, otherwise known as El Yunque Rainforest. And so we'll give you an overview of the program and then launch into some of the details of the Data Jam. And one of the things that I've really been impressed with, because I've actually been connected with the LTR program for almost 20 years. I first started working with them back in 1998 after Hurricane George, which had struck the rainforest almost 20 years ago, or 20 years ago in September. And that's one of the primary research programs of the Luquillo LTR program, is focused on the effect of hurricane disturbance on the rainforest, as well as how, as is projected by some of the models, that there's a prediction that there'll be a higher frequency of severe storms occurring, and how that might change the structure and nature of the rainforest. So as many of you know, Puerto Rico was struck by a hurricane back in the fall, Hurricane Maria, and I have to say it's extremely impressive how resilient these kids are. So you'll see these are some pictures from last year, but you also see pictures from this year where we have kids whose school doesn't have electricity. You know, they don't have electricity at home, but they're so devoted to science that, you know, they're coming out to the rainforest to do research. And in fact, Noelia is joining us from the rainforest, and the electricity is still being generated by a diesel generator down there. Oops. So as I said, we'll give an overview of the program, and we'll introduce the data jam, and then we'll have some opportunity to actually explore some of the data that we're using through Concord's CODAP platform. So the overall goal of the Schoolyard LTR program is really focused in general on promoting interest in STEM careers by engaging middle school and high school students in long-term ecological research. So this is a strategy that's across the entire LTR network. Each site receives funding for outreach within their community to extend the knowledge and resources of the LTER community to the K-12 community. So at our particular site, we engage in teacher profession development. We also do curriculum development, and we have programs to engage students directly with the LTER program. So here's the overall conceptual model for our Schoolyard program. So if we think about a teacher that is new to our Schoolyard program in Puerto Rico, the first way that they would get involved is through our data jam, which you'll learn about today. So they would be invited to a teacher workshop where we would show them how, what a data jam is and how to conduct a data jam. And then if they would then go back with their students, conduct a data jam, and then the final product that the students produce, they'll be invited to each May. We host a Schoolyard Symposium where the students actually share the results of their research. Those teachers that actually are successful at engaging the students in the data jam and having their students come and present at the symposium, we invite them to sort of take the next level of participation, which is through our field protocols work. And in that case, in the rainforest, there's a particular section of the forest that has been sectioned off, particularly for the Schoolyard program. And it's a place where the students then get the opportunity to actually measure and monitor the rainforest over time. And students as a whole are building up a long-term data set of that particular place in the rainforest. So the teachers then are invited to bring a classroom of students on a field trip to the forest, and then the kids take various measurements of the trees and the water and the soil that then gets monitored over time. And then they use that data that they've collected in conjunction with previous year's data to also generate some research project that then gets presented at the Schoolyard Symposium. And then further still, we have a very small subset of teachers that have also then set up schoolyard plots in their own local community that then they more frequently take their students out to collect data and monitor that plot over the long term. And then those students as well, their research projects, they get to come and present their results at the student symposium. One interesting feature of the symposium is that we actually have developed a partnership with another LTER site called Cevieta. They're based out of New Mexico, which also has large populations of Spanish-speaking students. So we actually host a virtual component where students in Cevieta present their research to the students in Puerto Rico, and vice versa. All right, so with that, I'm actually going to turn it over to Noelia, who's going to go into details about the various components.
Hello, everyone. My name is Noelia, and I'm going to walk you all through what we do here at the Schoolyard program in Luquillo. So as Dr. McGee mentioned, we have part of the framework I like to call like one avenue. So we invite teachers for a data jam teacher workshop, normally hosted by the Forward Learning company, and it's usually on November, although this year, due to Hurricane Maria, we have to move it, so we did it in January, so very recently. We have 18 teachers participating, which we were very happy with that number. It's usually open for 30 teachers, but over the year, we have between 17 and 22 teachers participating. So 18 teachers this year. That's a good number, despite the fact that they were going through a very difficult process in their schools. We basically present databases to them that has been collected by scientists from the Luquillo LTR, the Luquillo ZZO, and the US Geological Survey, and the parameters are related with hydrologic data from 1990 to 2016, as well as wet data from 1992 to 2011. And later on, when you are creating your own database or your own data jam, you'll be exploring this data into more details. Part of that workshop, we encourage teachers to develop a basic ecological question, develop a claim, evidence, and reasoning framework, and present their results in a creative manner. And all that happened within a 6-hour workshop period. The idea for them is to get exposed to the tool that they're gonna then bring to their classroom and present to their students. So for the students to develop data jam projects and come to our annual symposium. Here are pictures from this year's symposium. This year we have Dr. Stephen McGee. He came down and he helped us run the workshop. As well, we have some of the pictures of the interaction between teachers who have been with us for many years and new teachers. And on the picture at the lower end on the right-hand side, we have the interaction once they prepare their data jam product, and then they share to each other what the question was and the graph. So there's the interaction there. That's on the pictures.
So one side comment is this teacher here that's standing in the lower right-hand corner. So he actually is won the Teacher of the Year award for all of the island of Puerto Rico. So we're quite pleased to have him a part of our Data Jam program.
Yes, that's a very fresh news as last week. We're very proud of Elliot. So for the teachers who actually come to the data jam and develop the strategy and apply the strategy with their students and develop the projects, we then have the other avenue, which is inviting them to do the field protocols at El Verde field station. As Dr. McGee mentioned, we have a demonstration plot. It's a 30 meters by 20 meters that has been studied by our students since 2009. And so we have long-term data collected by students since then. Usually in a traditional year, again, we will have our teachers coming for a teacher training in November, and then between February and April, we'll have the students. Each of them choose one protocol that they want to work with their students, and they will come back between February and April for the workshop. It's like a school day. This year, again, our teacher workshop got canceled, but we decide to go ahead and bring the students between March and May. We had already conducted 3 workshops, and we're expecting to conduct 4 more before the semester is over. The topic areas in the past is been more focused on vegetation and forest dynamic, stream ecology, and soil characterization. But because of our hurricane this year, we basically adapt our protocols to some of the protocols that the LTER scientists are conducting in our forest. For example, they're doing a vegetation damage assessment. So we adapt the protocol and we're applying that assessment to our demonstration plots. So, and our students are collecting that data and developing some sort of baseline. Therefore, in the future, we will be adding new data and learn about how the forest is recovering from Hurricane Maria. As well with the soil protocols, we're doing coarse woody debris to try to see and catch rates of decomposition out of the material that just fall. So we're adapting this year and introducing the kids to a new set of protocols related with what just happened. Here are pictures of the happy kids in the forest. The upper picture are kids from a middle school in San Lorenzo, and the lower photos show some of some parts of the protocol. For example, the lower left picture there, the students are looking at with a compass at the direction of where the trees fall. So they're learning about, they're trying to predict the direction of the wind on Hurricane Maria based on the directions of where the tree falls. We have a student with a meter there learning about soil humidity and comparing like a high elevation point with a low elevation point and how that might be different. We also have a student using a densiometer trying to estimate the percent of coverage on our plot. And we also have students measuring the falling trees, DBH, and in order to establish that baseline. So there in the future, we can determine the growth of the composition or whatever, any other research type of idea that comes up in the future.
So one thing to point out in this particular picture, so this one is a recent picture from the rainforest, and just to point out how quickly the rainforest regrows after the hurricane, which was just 8 or 9 months ago. You can see there's still a lot of open air because the canopy hasn't recovered, but we'll see a lot of quick growth over the next few years to the point that the canopy will actually be closed in a few years.
And then the products of those two avenues will come together in May for our student symposium. This is a great opportunity for them to go to the University of Puerto Rico and present their findings to their peers. And then, for example, we now have a full day of activities, the morning time dedicated to oral presentations, and those are the kids who brings the data from their plots, and they also communicate their findings with students from Nuevo Mexico, from Escuela del Bosque. The Nuevo Mexico students focus more on the ecosystem around Rio Grande, and our students focus, some of them focus in a forest near El Yunque, but some of them are from other parts of the island, so often they bring information from the dry forest or from the Mogote area. So it's a very rich experience for them to present the different ecosystems in the island to kids in another part of the world. We have the afternoon for the Data Jam poster session. There the students interact with our audience in a very dynamic way. And we also set some time for them to kind of present their creative product and what inspires them to the entire audience.
And then one thing to point out in this picture is the gentleman here in the lower left-hand corner. He's actually the lead scientist for the Luquillo LTR program. So the nice thing for the students as they present on the campus of the University of Puerto Rico is that a a large number of the scientists involved in the LTR program actually come and interact with the kids and give them feedback on their posters.
Could you remind us what LTER stands for?
It's the Long-Term Ecological Research Program. We'll say more about the overall program, I think, in a few slides. One interesting story is there's a scientist named Bill McDowell who's a hydrologist, and it's his team from whom we got a lot of the data for the Data Jam. And he was at one of the presentations, and the kids were presenting, and they were talking about, well, we got this data from McDowell, and, this is what McDowell says. And then they just were floored when they found out that they're actually talking to McDowell. So it's quite a wonderful experience for them to be able to interact directly with the scientists that are collecting the data that they're using.
And in this slide, we're showing how the school partners are being increasing over the years. Before I call it the old framework, but it's probably a simple way of calling it. But we used to work with 3 or 4 schools in the past. By renewing our framework and revamp it, we are able now to invite new teachers and new school to participate in our program, and we has been doing that since 2015, and year by year we are seeing progress in the amount of schools that has been involved. Although this year we're still with the same amount of partnered schools and more or less the same amount of teachers, but we are increasing the student participation. The numbers on red are pretty much a prediction for the end of the school year. We are expecting to have been impacted approximately 150 students because I think the teachers that are now with us are very committed, and they often participate of the Data Jam, but they will also participate on our field work protocols, and they've been definitely bringing a lot more students into our program. So there's a lot of more exposure and impact from. So now that was part of the overview of the program. Now we're gonna.
Mm-hmm. Could I ask what grade level are the students that are doing this work? I mean,
Yes,
the middle school students. Are they all middle school? Is it middle school and high school, or
middle school and high school, both?
Depending on the teacher.
Depending on the teacher and the school, correct? Yes.
Thank you.
You're welcome. So we're now, after the overview, we're gonna go into the way we present the Data Jam to the teachers on the Data Jam workshop. Since you're all gonna be developing your own Data Jam, this is how we walk them through. So we introduce what Data Jam is. It's basically an interpretation and analysis of scientific data. It's a communication and dissemination through art to reach out to a broad audience. It's a teaching exercise where students have access to real data gathered from the LTR, Luquillo CZO, and the US Geological Survey scientists, and the data comes from a Junque National Forest. We develop a project, is part of developing a project representing the data in a non-traditional format, and we've been adapting this strategy from groups who has good experience with the Data Jam, as people from Jornada in Nuevo Mexico and the Asombro Institute, and also people from Baltimore Ecosystem Study and the Carey Institute.
And so I wanted to jump in, Noelia, because Philip had asked a question about, is something like this happening in the mainland US as well? So here is just an example of, there are other sites that are part of the Long-Term Ecological Research Program that also do the Data Jam program. But in terms of sort of the larger outreach efforts, bringing students to the specific LTR sites, so each site actually has an outreach program. It's not quite exactly the same as what we do, but each site sort of adapts outreach to their local teachers and students based on what the local needs are. Are we?
Stephen, are you linked with the Organization of Biological Field Stations that has an international network of such field stations doing various kinds of research, some of which might overlap?
So we're not sort of directly linked, but there's a lot of overlap between the two networks. And I actually skipped ahead a slide so that we can actually show the overall LTER network. So I believe that some of the LTER sites are also part of the Biological Field Station network as well. So there's cross-fertilization of ideas back and forth between the two networks.
Thank you.
So to answer the larger question of what LTER is, it's a network of sites around the mainland US. There's also the Maria Islands, which is another territory in Puerto Rico. There's 2 sites down in Antarctica and a couple of sites up in Alaska. The program dates back to the early 80s for some of the initial sites. But the idea is that NSF had sort of a long-term vision that we really want to understand what's happening over time at specific ecological locations. And the sites are distributed across a wide variety of different ecosystem types to give a good sense of sort of what are some of the local issues, but then how can we understand across all these sites sort of what are some of the large-scale factors that are changing over time. And each site has built into their scientific funding a pot of money that's dedicated specifically for outreach. And the nice thing is that each site can design what's the best way to conduct their outreach based on the needs of their local community. So the Data Jam program is something that a handful of us sites have really been pilot testing and developing, and we're starting to get interest in some of the other sites interested in also doing Data Jam. But there's just a wide variety of professional development programs and field trip activities that occur across all the different sites.
This is
And
great, Stephen.
Backtrack. Oh, go ahead.
I'm sorry, are you seeing some of the questions in the chat back channel, Stephen and Noelia?
Yes. So let's see. So they both collect data and analyze existing data sets. That is correct. So the Data Jam, which we're going to delve into a little bit more deeply, we've taken the long-term data that the scientists are collecting and have made sort of easily accessible versions of that data for the students to conduct their own analyses. But through the field protocol program, the students are collecting new data for that specific demonstration plot site, and we are organizing that data within the framework of how the LTERs manage their long-term data. So kids can also use that data to analyze as well. And then the second question, do students use their own data for their project or the existing data sets? That's an option for the students. So some of them actually use the data that the student collected data from the demonstration plot. For those 3 schools that have been with us for a while and have their own plots at their schools, some of the sites actually use that data to come and present. But they don't actually, there's not a sense in which the data that they're collecting usually is not a project in and of itself, because the focus is really on long-term data and long-term trends. So whatever data they collect, they would combine with the other data sets or the other data that's been collected as part of that data set to then look at the long-term trends. All right, so back to you, Noelia, if you want to sort of introduce the various folks that have been involved with us.
Yes, so as you know, Dr. McGee has been involved with us through this process, and Dr. Jess Zimmerman, who's our principal investigator of the Luquillo LTR, Dr. McDowell, William McDowell, from also the principal investigator of the Luquillo CCO. Alexis.
I guess we should also say, Noelia, we're not going to talk that much about it here, but there's another network of research sites called Critical Zone Observatories. And it just so happens that Luquillo is part of both the LTR and the CZO network. And the critical zone is basically the bedrock to the treetops, is sort of that whole part of the Earth system, from the geologic to, and the interaction between the geologic and the biological systems. Whereas the LTER program is basically focused on the soil to the treetops. So it's a little bit of a different perspective, but we're drawing data from both of those programs.
Yes. And also we have a partnership company, Forward Learning, and from there we have the support of the president, Alexis Torres, and we work very close with Mayrelis Narvaez, who's an educator consultant and very often participate very actively with us on the Data Jam workshop. We also have been given a little bit more support into how to create a scientific poster, and that she's also lead that effort together with us. And we also have Dan Damelin from CODAP, from the Concord Consumption, and he's a CODAP developer, and Miguel De Leon, the information manager from the Luquillo CCO, who has been very committed to develop the website where we can put all the information related with the Data Jam in a more organized way, and also make the data available to the teachers and the students to be used. And you'll take a look of that link later on. So here's the, I guess, yeah, we're going back now, Stephen?
Yes.
So, okay. So the Luquillo LTR Ecological Research, the study site is at Yunque National Forest, and on the map is part of the northeast corner of the island. The research here began in 1988, and the framework is oriented toward what are the short and long-term effects of drought on biota and biogeochemical cycling in tropical forest. What are the effects of increased frequency of intense hurricane on tropical forest biota and biochemical cycling, and how do change in climate interact with hurricane disturbing land cover and land use legacy to shape ecosystem of the future. So basically, we try to develop our learning strategies according to the science that the Luquillo LTR is conducting in our national forest. Here are the part of the Data Jam that we're asking the teachers to develop with their students. It's a poster session, it's a poster format, excuse me. They will need titles, they will need the students and the school name, they will need to introduce their databases, they will develop graphs that show some patterns of the data, they will do an interpretation and analysis of those graphs, they develop a research question or a hypothesis, and they develop a creative product where they can basically explain to any non-science related person what the data means. We ask for a dissemination plan and also a reflection of the whole experience. Here's an example of the Data Jam poster from Ernesto Ramos Antonini, Specialized Art High Schools in Yauco, and we also have one of the creative products of one of the paintings from the middle school in San Lorenzo. We also have a created product list, and the sky's the limit. They could develop anything they want. Song, poem, storybook, videos, infographic, and sculptures. We have the girl in the upper corner. She developed a story of Rio Mameyes, where she basically explained the difference in the stream flow when we have the impact of a hurricane, but she did it in a very artistic way, and a very very nice way. So she make a storybook of that relationship. We have a display, and we also have a song that kids, I think in 2017, wrote, and it was their inspiration, and that was their creative product. I believe Dr. McGee is
we're gonna
share some of that.
Yeah, so we have to warn you, it's a little catchy, so it might get stuck in your head. But in 2015, which you may have seen on the national news, was a severe drought in Puerto Rico. So these poor students have sort of had a back-to-back severe drought with water rationing, and then a couple years later have to survive a hurricane. But the kids did their data jam, sort of exploring the effects of drought, and then wrote a song, which we're going to play for you.
Puerto Rico had a drought, and we'll tell you what it's all about. From February to November, we can't even remember.
We had scarce water supply, it almost even made me cry. So we started investigating, and we thought global warming.
Global warming, it's a warning. We are burning through our journey. Take the mic, JP.
There is so much heat that I'ma bring this beat. We be doing so much harm, be the reason why it's warm. What's done is done, but not everything is gone. If we don't try, we might as well say goodbye. Earth, our birthplace, something we can't replace. We can get things back, but knowledge is the thing we lack. All of us, stop and analyze. We need to realize, we need to be the one before it's too late, so we become none. Take it back, Jay.
Puerto Rico had a drought, and we'll tell you what it's all about. From February to November, we can't even remember. Global warming, it's a warning. We are burning through our journey.
So when we introduced the Data Jam strategy, we also explained the teachers the relationship with the next generation science standards and how this strategy is it could be very well integrated in what they do, and it covers the standards in terms of analyzing and interpreting the data. Oops, sorry. Can you go back one, please?
Oh yeah, sorry.
Using mathematical and computational thinking and engaging in arguments from evidence, obtaining, evaluating, and communicating information. So they could definitely develop data literacy skill by applying the Data Jam and incorporating in the classroom. Their teacher role is helping the students with the data selection, visualization, and interpretation, encourage them to spend some good time on the project, and evaluate, or evaluate them through the whole process, motivate them to develop a creative component, and perhaps incorporating other teachers into the whole dynamic, help link the creative project with the Data Jam. And this is a very challenging one, but we're working on it, and other sites have been very, very much into developing guides in order to for them to try to link. It's not necessarily an easy thing to try to link scientific data with art, but anyway, that's an area that we're gonna continuously working. And they participate in the annual symposium, and the teachers often go with them to the annual symposium and support them through that interaction. And sometimes they even go further and they all get invited to present in our annual scientific meetings, and they all go as well and participate and present their posters in that scenario as well. Any question?
All right, so we thought before we launch into the data jam, we can pause here if there are any questions or comments or discussion points before we launch into actually working with some data.
So do you know much about the conceptual difficulties that teachers and students encounter as they begin working with you in Data Jam?
Well, that is an excellent question, Bill. And so as an outreach program, we actually get a very small pot of money, which actually goes into mostly running the program. But we've actually been collaborating with Concord and some of the other sites to seek funding from NSF to actually do the kind of research to understand the conceptual difficulties that students and teachers have. I'll show a couple of examples, but I think one of the things that I think we're seeing is that that there's a mindset shift in sort of how to think about data, that oftentimes I think the natural tendency is to take the long-term data and just graph it over time. If you want to compare two things, that then you'd graph both of those things over time and kind of look visually to see if there's any pattern that I notice. But what we're not seeing is sort of a tendency to think about data in terms of distributions or in terms of looking at scatter plots and things like that. So that's an area of focus that we've had this year, particularly with the use of CodeApp, to help sort of shift that orientation to think about it from more of a data distribution level rather than just looking at data over time.
Thank you.
Can you say a little bit more about the partnership with the schools and recruiting schools to participate? Are you working with school districts, or are these teachers that are familiar with your program through other means?
So I'll start and I'll let Noelia jump in as well. So the first thing is that the entire island of Puerto Rico is considered one school district. So it's pretty large geographically, but in terms of size, it's not that much different than some of the other large school districts that we have around the mainland U.S. So one of the things that's been really helpful is the partner that Noelia mentioned, For Learning. They do a lot of work with schools, particularly in the area of science. So we've tapped into their network of schools. But this is also something where we've worked directly with the state science supervisor or the district science supervisor, who has also advertised the program as well. But Noelia, is there anything else you want to share in terms of the specific strategies for reaching out to schools?
Yeah, there are also regionals and facilitators that I've been meeting through a bunch of numbers of activities that we get involved. Often participation and partnership with other programs that we collaborate with often invite us to put tables with information, and if there's an activity open to the public, I have met some teachers that way as well. Others has been recommended by the teachers, and some of them have invited other teachers from the same school or friend or somebody who they know will be interested in participate. So the list has been increasing by many different ways. Sometimes I run into teachers in activities and I just introduce the program and they just, I want to be part of it, and they become part of it. But it's, yeah, that's mainly how we communicate about the program, and therefore how the teachers get to us.
And what we're finding is that once teachers join and actually do the data jam, that they come back year after year. So, you can see from the numbers that we're just sort of gradually expanding. And the nice thing is that once we get people involved, they tend to stick around.
So Annette asks, what do you think motivates teachers to participate in a data jam rather than a science fair? Is it the art, the common data set analysis, your workshop to support the teachers?
I think it's not a competition at this point. And that's something we've been kind of, that's a different way that we have developed our data jam. At this point, we don't do a competition. And I think that opens up a little bit more for those kids that often feel like, well, I might not gonna do it. I don't have an original research to develop here. Like often scientific fair, you're asking, or students often think that they have to come up with this original research question. Here, we're facilitating a little bit by giving them some data and some themes that they can then think about it and develop a research question. So I think that's, in that way, it's maybe more appealing, perhaps. And also, it's not a competition. They just develop the research question and they present at a symposium. And the pressure on the evaluation aspect of the project is not very strenuous. It's very friendly. Let's put it that way. So I think that could be perhaps the motivation, in my opinion.
It's not exclusive. So we do have a number of the schools actually engage in a variety of different science activities. So some of them might be doing science fair anyway, in addition to doing something like Data Jam. And certainly I think a big motivator is that, so the El Yunque forest is actually one of the crown jewels of the island of the Puerto Rico. And it's something that I think across the island, folks are very proud of El Yunque. And so it's also, I think, a motivator to have the opportunity to actually engage with doing research on something that culturally is very important to folks across the island.
And Philip asks, where are the poster presentations made?
Where are they made?
Where do they take place?
I'm sorry, the poster, designing the poster and printing I'm sorry, Bill, can you repeat that question? Sorry.
Philip asks, where are the poster presentations made?
Well, I guess there's two ways to interpret that question. So one, in terms of the actual, how the posters are made, either they do it at the school or, the Schoolyard program actually supports printing out the posters for them. But the actual poster fair or symposium takes place on the campus of the University of Puerto Rico.
On the annual symposium, yes.
So although last year it actually took place at a nearby school, but it's centrally located. It's important for us to be near the campus to give opportunities for the scientists to also participate as well. These students and teachers are motivated because they come from all over the island, which could be an hour drive to get to San Juan. And so I'm always impressed with the motivation of the students and teachers to really participate in this. I'm sorry, I interrupted somebody asking a question.
Yeah. Hi, I'm Joan Heller. I've been evaluating, one of the evaluators for CODAP and the Data Science Games projects. And in watching students learning how to do the kinds of things you're having students do, we see that obviously not every graph is ideal for showing what they want to show, or sometimes, there certainly is a amount of learning that has to go on about how to show certain kinds of relationships. So I was very curious whether there's some kind of a feedback or, how both the teachers and the students can, learn what might be a better way to do things as they're developing their projects.
Yeah, I think we're definitely open to suggestions for how to do that better. So one of the components that Noelia alluded to is that when is it upcoming, the poster session? Is that this April, coming this month, Noelia, where they come back?
Yes, April 20.
April 20th. So then the students that have registered for Data Jam and have kind of draft posters, then they actually will come to a workshop at Forward Learning where they'll get sort of a workshop on basic presentation and poster development skills, and then we'll have some opportunity to get some feedback on their poster prior to the actual symposium in May.
That's one way, and then, I'm sorry, Stephen, to interrupt, and then this past teacher symposium, workshop, we took some time, Dr. McGee kind of presents some of the graph that have done in the past by some of the students, and he gave suggestions of how to improve that graph. And this
I didn't give suggestions. We had the teachers actually.
Yes, the teacher each got a copy of that graph. They gave suggestions to how to improve, now based on the knowledge they have, how to improve that graph. And then, of course, we conduct the interaction there. But yeah, thanks.
Yeah, so we're trying to build the capacity of the teachers to provide feedback to the kids as they go through the Data Jam. We have a question, can we share the resources used on poster development skills? I would imagine, right, Noelia, that whatever Forward Learning puts together, we can add to the Data Jam site?
Yes.
So if there's no other burning questions, I think we can launch into, this looks like we have plenty of time to actually work with some of the data. We're going to try a new feature that none of us have used on Zoom. We'll see how it works. So this is a map showing the location for some of the data that we'll be using. It's not ideal what we have in terms of they're not necessarily the same geographic location, but they kind of give a sense of some of the relationships that we're having the students explore. This location here, El Verde, is actually where Noelia is at the moment, which is in the rainforest. That's the field station where the scientists, sort of the launching point or base camp. From there, then there's the plots are nearby El Verde. So the Rio Icacos is where we have stream flow data over the last, I think, since 1990 or the early 90s. Maybe getting this, and I'm not remembering. Oops. So one of those sites, sorry, I'm going backwards. Maybe getting these backwards, but one of the sites is where we get the stream flow data, and I don't know why it keeps going backwards. And then the other site is where we get the rainfall data. So they're not exactly the same site. And then Lago Luisa is where we actually get reservoir height from. And then we also have a long-term data set of storm events, which actually comes from El Verde. All right, so now back to Bill's question of what are some of the difficulties that students and teachers have working with long-term data. So these are two examples from the data having to do, the hydrological data in which we give rainfall, stream flow, and reservoir height over, I think it's like 15 or 16 years worth of daily data, so it's a lot of data. So one of the things that we typically have seen students want to do is to compare two different years. So in this case, since 1994 was also a drought year, and 2015 was a drought year. So this particular student decided that they wanted to see, well, you know, which drought was worse, and to then basically graph. This is daily rainfall data from January through December, and the blue line represents the daily values for rainfall in 1994, and the orange values represents the daily rainfall in 2015. And then this is what they use to try to interpret, was there more, or which drought was worse, 1994 and 2015. And what they have a tendency to do is then look at the most salient features, which is they might interpret, oh, well, in 1994, we had these very large rainfalls that occurred, you know, in the spring and then in the summer or the late fall. So maybe there was more rain in 1994. You know, they could also look at and say, well, looks like the bumps are higher in the orange overall, so maybe there was more rain. But either way, you know, it's really not the right representation to really compare two sets of data. And what I have underneath here is actually a seventh grade Common Core Statistics and Probability Standard, which focuses on the idea of actually comparing, if you want to compare two different sets of data, that you actually would compare the distributions of data to look at and compare the measures, some measure of the center of that distribution of data relative to the spread or variability of that data. The other example here is where now within 1 year, which is the drought year, this particular student wanted to compare, is there a relationship between the amount of rainfall and then the subsequent stream flow, which seems like that would make a lot of sense. But once again, they basically graphed the daily values over time and, you know, did some sort of visual interpretation to try to interpret whether or not there was a relationship between these two variables. So below that, I give an 8th grade Statistics and Probability Standard, which talks about constructing scatter plots to then look at the association and the patterns of data between the two data sets. One of our suspicions is that, so prior to this year, we had supported the teachers and students in using Excel as the platform for graphing their data, and graphing data over time like this is one of the most salient approaches to working with data. And this year we've introduced CODAP in a pretty significant way and talked about and showed how CODAP actually can facilitate these other representations of data, of looking at distributions as well as generating scatter plots. So with that in mind, I'm going to end the presentation. I think I might actually have to stop sharing and resharing because I only shared PowerPoint. I'll just share my whole desktop. Okay, so I'm going to take this link and share it in the chat. That go. Uh-oh.
I think you need to stop screen sharing first, Stephen.
Oh, I had the chat open before.
Yeah.
Okay.
There we go.
Exit full screen mode. Where did my chat window go? Maybe, Natalia, you could paste it in the chat window for me. I've lost the chat window.
Yeah. Is this the Google Doc that's shared earlier?
That is, you'll need that link as well. So we're actually going to use that to have you share what you learned from your data jam. Mm-hmm. So the link that Natalia just shared, you can go to that link. So this is the website that we use for sharing the data jam with the teachers. And I will go to that site myself. Oh, I already had it up. Actually, I think what you'll see. So this is the website that we use to support the data jam. And based on the suggestion, I think we will, whatever associated resources that we have related to the poster guidelines, we'll also add here to this website. You can click on the Schoolyard Data Jam dataset link. And one thing you may notice is that this actually is We have it posted on the Critical Zone Observatory website. And if you actually explore it around on this website, you'll see that the data is actually stored, presented, and cited in the exact same way as the scientific data, other scientific data sets are reported. So we really want to give students a sense that this is real data that they're working with. So we provide a version of the data, the hydrological data in Excel, and we also have a wet event data set in Excel. We have two versions in CODAP. One version is the full data set, which particularly for the school computers, they don't necessarily have enough horsepower to actually work with the entire data set. So we also have one in which we reduce the number of years that we provided, just so it's a little bit more manageable. And so what I'm going to do is actually click on that particular link. And so certainly Natalia and Dan and Bill, feel free to jump in on anything having to do with CODAP, since you all are the experts. But this is the hydrological data that we've put into CODAP. If you mouse over the, oops, I clicked. If you mouse over the various, the variables, it gives you a little bit of the metadata about each of the specific variables. So this set of data here is each row is a specific day dating from in this case, 1993 through 2016, skipping over specific years. We could then aggregate the data so that then we have now data aggregated by month within each year, and then we aggregated the total for years. So we don't have any variables by month, but we could add that. But we did actually come up with a total rainfall variable that calculates the sum of each of the days in that particular year. So you can see the select years that we provided. And to create a graph, you just click on Graph. And up pops a graph window. You can see that's a lot of data. And what CODAP does, it initially just randomly places the data points within the graph window, and then we can gradually add structure to the data by moving our variables either to the X or the Y axis. So one thing that we may want to do is just see daily rainfall over time. So now we have a histogram of, and the y-axis is actually a count of the number of days that have each of those values. So what we can see is that most days there's not a lot of rain. But then we have other days where, boy, that's a lot of rain in one day. So what we can also do is we could take year, and then we can actually color code. If we drop it into the middle, we can now color code each data point by year, which for this amount of data really doesn't make a lot of sense. It's really hard to sort of figure out what is going on. One nice thing is that then this legend at the bottom is interactive, and so we can actually select specific years that we're interested in. So I might select 1994, which is one of the drought years that we know of, and you can see in the graph that each data point in 1994 is now highlighted with the yellow circle. If I hold down the Shift key and click on 2015, it now adds to the selection. So I now have both all the data points in 1994 and 2015 are now selected. If I go over here to this little eyeball, I can now hide all of the unselected cases. Oh, that didn't work. Ended up with
Oh,
19,
yeah, that's a bug. That's a bug, Steve. That's fixed. Will be fixed in the next release.
Oh. Well, it was working previously when I was trying this out just before the webinar. I think it's one of those webinar-itis bugs that only happens when you're actually doing a webinar.
If I could make a suggestion.
Yes.
Drag year to the y-axis.
Okay. Well, I'm going to do that. So, but this was the other way that Dan taught me. So if you click on show or hide parent visibility toggles, I can now toggle 2015 and 1994. Oh, but it still shows. Okay, so now I'll drag year over here. Ah, I see what you're saying. So it actually was the right set of data, it was just the wrong legend.
That's right.
Okay. Anyway, this is where I was trying to get to. So if you recall from the previous set of slides where I showed the graph where the students graphed the 2 drought years over time, what we want students to be doing is to actually compare distributions. So as you could see, it's except for the minor bug that Bill pointed out, it's fairly straightforward to set up a comparison of the 2 different distributions between 2015 and 1994, so we can begin to ask questions about, well, which drought year was the worst between these 2? Another nice feature in CODAP is if you come over here to this ruler, it actually provides some statistical values that we can apply to the graph. So we can ask it to plot the mean value for that particular year. So we can see that the mean value in 2015 is actually greater than the mean value in 1994. But as the Common Core standards suggest, we want to actually compare these in terms of some measure of spread. So we can also put the standard deviation on here as well and begin to have discussions about, okay, there are differences, but are those differences meaningful when we actually look at the average spread of the data? We can also think about, there are some outlier values in each of these particular years, which are very different than the general trend of rainfall in any particular year. So you just basically have a handful of days where there was a very strong storm event that occurred. So what we might want to do is to say, well, let's actually explore what this data looks like if we actually eliminate all these outlier values, and let's define that, say, any daily rainfall that was over 20 millimeters in a particular day. I can drag and select all of those. And now in this case, I would say hide the selected ones, and then the values are recalculated now relative to the various the remaining distribution of data in that particular graph.
And Steve, if you click on the top icon there you go.
So then it regraphs it based on the distribution of data that we have.
Comparing very skewed distributions is a tricky thing.
Yes. Looking in the chat box. Oh, so good to know that there's now Spanish translation of CODAP available, so that's really helpful.
And you can access it with that flag in the upper right of your window there.
Oh,
Wow.
cool.
If you don't save your document first, you will lose these changes.
Okay, well, we'll stay in English for now.
So could you graph total rainfall by year?
Yes. Let's make a new graph. Oops, I did a map. Another cool feature, but not one that we use in our project at the moment. So now we can just take year and, oh, and then we want to put total rainfall. So this is one of the things that would be a handy way to sort of look at. We're comparing basically the two lowest rainfall total amounts during that time period. But we could also explore what is the highest amount of rainfall versus the lowest amount of rainfall per year. Okay, well, we'll come back to that because we're going to give you some time to actually explore data on your own. But I wanted to quickly show what a scatter plot would look like so we can recreate the graph that the other students had done, which was, oh, we still have daily rainfall, but we want to put, now let's put stream flow on the axis, and let's actually do show all cases in this case. So here we have a scatter plot, which would be the more appropriate way of comparing, let's see, actually, we'll do hide unselected. Oh. Actually, how do I want to get the, I want to recreate the 2015, so I'll quickly hide all these other ones. Just pop up 2015. So now I recreated the graph that we saw earlier, but in this case with a scatter plot. And then we can now look at some of the statistics related to scatter plot data. So one of the nice things is we can do a least squares line data to show, oh, yes, there is a somewhat of a relationship between rainfall and stream flow. Then, of course, the interesting thing is to begin to look at the relationship where you have these outliers where, you know, particularly if we had low stream flow, I mean, low rainfall, but that ended up with a lot of stream flow, we might want to investigate what's going on with those particular data points.
So as a CODAP developer, Steve, I'm very interested in your experience with the students this time around with CODAP, whether you observed differences.
Well, we'll find out at the end of May.
I see.
There were a couple more questions that showed up in chat. The first one is actually from a while back.
Okay.
Richard had a question about the A&D data in Oregon. Let's see if I can find it. It's going to require a bit of scrolling, sorry.
There was a location in Oregon and Washington area defined as A&D. Can you provide?
Oh, okay. Yes, that is the Andrews Forest. And yes, I could, the woman's name who's the outreach coordinator is Kari O'Connell. And I can provide her email address.
Great. Okay, I'll try and connect you with Richard, Stephen, so you can get that.
So then the other question was, how do the students get these data? So it's from the website that we provided. This particular set of data is not data that the students collected. This is data that has been collected by the Long-Term Ecological Research Program I believe the stream flow comes to us from the US Geological Survey. They have a stream gauge that we grab the data from, and then the Critical Zone Observatory is providing data as well. So that link that we provided is where the kids access the data, and then they come here to CODAP to graph that data. So actually I'm going to leave this, and I just wanted to quickly show the other data that we have available. So here we have data from roughly the same time period, 1993 to 2003. But what's different about this data is it's not, the rows in this case is not time bound in the sense of amount of rainfall per day. It's actually the amount of rainfall by event. So anytime that it rains, they record from when the rain starts to when the rain ends, and that's the event duration. And then they also collect how much rain fell during that time period. So each row represents a specific rain event. So once again, if we just click graph, then we can get a random set of distribution of the data. And then we can graph what seems quite logical is the event duration and how that affects the amount of rain, which will give us a scatter plot.
Wow.
And then we can again put a least square line on there, and it explains about half the data, the event duration does. But then once again, it's very interesting to then explore, actually we go all the way to 2017. So if we go down here to the end, you'll notice two data points that we plotted, which are actually, this is Hurricane Maria. This is Hurricane Irma, which skirted the island about 2 weeks before Maria. And then this is actually Hurricane Maria. So it's the amount of rainfall that fell during that 48-hour period during the hurricane. We might also wonder, what is this other data point here? And so the nice thing is you can click in CODAP, and it also highlights that data point in the data table, and we can see that that is from September 9th, 1996 to September 11th, 1996. One of the things that we then provide is actually a link to a weather website that actually records significant weather events in the various ocean areas. So if we look at the Atlantic from 1996, and those folks down in Puerto Rico may actually remember this, but 1996 was actually Hurricane Hortense. So then we can scroll down here and look up Hurricane Hortense, and we can see the hurricane track. So this particular track skirted the southwest corner of the island, so it didn't actually have a direct hit on El Yunque, but of course brought lots of rainfall to the forest, even though there wasn't significant wind damage that occurred. So those are some of the kinds of things that kids are able to explore, both in terms of wet event data, as well as looking at some of the hydrological data. And then what we'd like to do in the last bit of time that we have here for the webinar today is to actually split up into small groups and have you all work as small teams to actually do kind of your own little mini data jam. So you can pick either the wet event data or the hydrological data and come up with some sort of interesting graphical analysis of that particular data. And then what we'll ask you to do, and I forgot to show this feature. I'll share my screen again. So in the graph, you'll notice there's a little camera. And if you click on that camera, then you can export the image. Probably the easiest thing to do would be to sort of save it to your local hard drive, and then we'll ask you to actually upload it into the Google link. And Natalia, maybe you can post the Google link again. And so now I'm actually going to turn it back over to Natalia, because we're going to try a new feature of Zoom that, well, it's not a new feature for Zoom, but a new feature for us of actually splitting the group into small teams. And each team then will use the link to explore some data and then share your graph in the Google Doc.
Okay. And Stephen, just to confirm, we want 2 to 3 participants per room?
Yeah.
Okay. So I'm going to assign 12 of you into 5 rooms, creating breakout rooms. And I'm just checking the distribution here before I...
Oh, and I should say we'll probably just give you 10 minutes to work together, and then we'll come back as a group and sort of share out some of the things we've learned and then have some more discussion in the last 10 minutes.
Okay. So hopefully we're all feeling ready. I'm going to go ahead and open up the rooms. This is my first foray into something like this. Let's go ahead. Okay, so I have feedback that all participants have been invited to join breakout rooms back here. Okay. Noelia, did you receive an invitation to join a room?
Yeah. Yes, I did.
Okay, so you can go ahead and follow that, and I think that you'll be good to go. Stephen, I'm seeing that your 2 participants have not joined breakout room 2. I think I'm going to move you to breakout room 4, if that's
okay. I wonder if we actually lost, looks like we lost a lot of people.
Yeah, we lost a few who said they were going to bail on some of this. But let's try this. A few people tend to drop off, by the way, at 10 a.m., I find, just because of the 2-hour format. Probably should have warned you about that.
Oh, that's all right.
Okay. Are you able to join breakout room 5?
I haven't gotten a notice yet.
Let's see. Try you one more time. Try clicking on the breakout room link that I shared with you earlier.
That's my chat window. I don't have a link anywhere. Oh, there it is. Join breakout room down at the bottom. Okay.
But also notice that you guys do some things differently in Puerto Rico, which is cool, because ours is a competition, but yours is more open.
Yeah, that was one of the modifications. I mean, we adapt the whole strategy from you guys and the really want to compete in that aspect. I mean, there's other opportunities, but for this one, in terms of STAR, we didn't feel like, you know, like doing a competition right away. That maybe in the future, as it is evolved, maybe could be another aspect that we could add. And I think, you know, right now, one thing we're noticing is as we grow, but we don't necessarily, sorry about that noise, I'm gonna feel free. As we grow, that competition might come with the whole package, because, for example, students, teachers are now starting to get the sense that we want them to present the data jam to the entire classroom, but as a program, we might not have the availability to receive all those projects into our symposium, for example. So maybe down the road, they might do want to try to do a little bit of competition between those students, and then bring one or two to the following step. So I think eventually the competition might take place that way, but it's not like first place, second place, and like you know from your side the way you do things. So
Right, that makes sense.
yeah, that's where we're seeing things moving to. Yeah.
So we have another person who joined our group.
Oh, hey, Natalia.
Natalia, just came to check in, see how we're doing.
Oh, yeah.
I'm hosting.
We've digressed.
Yeah. I saw your comment earlier, Tarnaria, about the how data jams are done in Baltimore versus other areas. That was really, really interesting.
Yeah, we were just talking about that. I think it's really cool. And I mentioned to Bess earlier, it'd be interesting to get like all the students who either win from our sites or who are participants at other sites together for one big symposium. But that's my forward-thinking dream.
That's a good idea. Yes.
Well, and maybe, you know, if our DRK-12 gets funded, we might have some more cross-pollination between the sites that are hosting data jams.
I am really hoping for that discovery research proposal that Dr. McGee and Alan and other folks submit, because that will definitely help us, you know, come more together and formalize the whole data jam strategy and develop more materials for maybe make it a little bit more consistent among all the sites, and learn from each other, and more interactions, and have them interacting, and more coaching for the teachers too. I feel sometimes that we don't give them enough coaching.
Right. No, that's true.
No.
Are the field trips that you bring, the kids come out, that's during the school day, right? It's not on a weekend?
No, actually both. Right now we have, it's mostly during the week, but right now we have the water protocol led by one of the professors at UPR, and he can only do it on the weekend. So we're flexible about that, because he's the person who runs them. So, and he's been with us for many, many years. So it's a great resource. So we manage the water protocols this semester are going to be on Saturdays.
And do you pay for the buses, or the schools have to pay?
No, the school pays. Yeah. We don't pay for the buses. We don't pay for lunches or anything, water, nothing. Right now, we're not paying for much.
Okay.
No.
Okay, let's get to our assignment, I guess.
All right.
Do you want to share your screen, Tanara? Or I have a graph up. I could share mine.
Okay, that's fine. It doesn't matter. I have mine open, but you can open yours. You can share your screen.
All right. What do you see? Can you see? What do you see?
Yeah, I can see it.
The Kodak screen? Okay, I just was messing around with it, and do you see my mouse too?
Yeah.
Okay. I just did reservoir height on the y-axis and year on the x-axis, and then I put the little average bars in there. And yeah, I don't know. I guess I was interested in how high the reservoir got. And since the reservoir height is measured by day, I thought that didn't really tell me enough. as to what was going on over the course of the year. So that's why I put the mean for each year in there, so I could get a better visual of kind of overall for the year, how much water was in the reservoir. So can you hide then the data points and just have the mean in there?
It is possible to hide the points if you click on the little icon, I guess.
Yeah. Hide unselected cases. Will that get rid of the?
That will get rid of all but the one point you have selected. Are you hoping to select for just a year?
No, I just wanted to show the average, like leave those average bars up there and get rid of the data points themselves.
Oh, okay.
Can you do that?
Yeah, there's a nice way to do it in a table that I know about. So go to the years case. Yeah.
The year?
Yeah, you're going to want to create a new attribute.
How do I do it? You have to remind me how to do it.
Yeah, so click on the plus button, the gray plus button. Yeah.
New attribute in years.
Yeah,
okay.
that's one way to do it.
Got it. And then just put average reservoir height or something.
Yeah, beautiful.
Average reservoir height. Okay.
And click enter. And now click on the attribute name. Just there. Yeah. Click on the gray box that was created.
Oh, whoops. No, did the wrong thing.
Yeah.
Okay.
Now go to edit formula.
Edit formula.
And let's say mean. Yep. And then click on the, yeah, and then the name of the attribute is total rainfall, it looks like.
Or I wanted the reservoir height.
Oh, the reservoir height. Thank you. So,
can I click on that or do I have to type it in?
Yeah, go ahead and do you see where it says insert value?
Yes.
Yeah. So,
okay. Reservoir height.
There you go. Yeah. And now apply. And I have it. Graph it if you want.
And I can pull that over here.
Exactly.
Sweet. Okay.
Yeah. Looks great.
I like it.
Yeah.
Should we, what do you guys think? Should I take a picture of this thing and put it in the Google?
I think that sounds great. Very nice, Bess.
Okay.
Yeah, looks good.
Yeah.
Support image. Great. Yeah, please.
Yeah. You guys feel free to keep creating visualizations if you want. I'm just going to check in with the other breakout room and see where they are. Are you ready to go back to the larger group if you want, or do you want to keep working here?
No, I think we're good.
Okay. I'll be just a second.
All right, so.
Hi. So our group in breakout room 4 is ready. I just want to check in how you guys are doing.
Yeah, we're ready.
Well, you should tell the group 4 to make sure they paste their graph into the Google Doc.
Yep, great. Bess is working on that now. So I'm going to go ahead and stop the breakout room. I'll give us a second warning before we join.
Perfect, Talia. Thank you.
It was cool.
Thanks, Bill, for being the driver.
59 seconds. All right.
Okay, I'm back, Stephen.
Okay, I'm back.
Okay, I think the rest of us will be back in 60 seconds.
And we have a different view of you.
Yeah, I decided to go get away from the Zoom room west while I was doing this.
Oh, okay.
Yeah, this is fun.
So were there just 2 breakout groups in the end?
That's what happened in the end. I tried to create like 5 breakout rooms with 1 facilitator each, but then since a few people are muted or not showing video, I ended up like rejiggering it a little bit so that we could have more participation.
Yeah, I'll have to figure out, is that because I have a Zoom account, so I have to figure out how I can add that to my account.
Yeah. I had to upgrade Zoom just to get to work.
Oh, okay.
That was
Hello.
cool, Talia.
Well, thank you.
I like that breakout room feature. That's super
Hi,
cool.
Talia. Thank you.
Thank you. Thank you. That was fun. It was Steven's idea, so I can't take credit there.
This is cool. The group work is cool.
I suppose Beth and Tanara were in the same group, huh?
Yes. Sorry.
Yeah, we thought that was funny too, that we got grouped together since we're from the same site.
Of course, I don't know that Natalia knew that you were from the same site.
No, I did not.
So do we want to just quickly share what the two groups came up with?
Yes. Do you want to share screen, Stephen, or do you?
Sure, I'll share my screen. So let me click on the share screen thingy again.
So do you actually think of this as a mini data jam, Steve?
Well, somewhat, yeah. I mean, you've sort of done the beginning part, which is, you know,
With the data.
I'll talk about our group in that we sort of played around with the data a little bit, and then Christian had suggested, oh, I wonder if there's seasonal patterns to the rainfall in Puerto Rico. And I'm sorry, Christian, did you say you're in Brazil?
No, I'm based in Buenos Aires, Argentina.
Oh, Argentina. Okay, sorry. So I think in your area, it sounds like you have some seasonal rain patterns, and so you wanted to see what it's like in Puerto Rico. So fortunately, we had Bill on our team who was able to, we were able to then create monthly rainfall totals by adding a variable and then graphed that and added a box plot. And this is what our data looks like. And we just started the interpretation of whether or not we thought there were seasonal patterns to the data when it was time to come back together. But in terms, this is the kind of exploration that we hope would happen with kids, that you kind of play with the data and come up with some questions and then try to then create a representation to answer your question. So if we liked this representation, I think then what we would have done is then fleshed it out in terms of what our question was and had sort of a more thorough discussion of the data. And then we would try to come up with some creative way to represent what our findings are. And then that's what the data jam would be.
So, of course, Group 5 wants to know, do Puerto Ricans view February and March as the dry season? Or are these variations not significant enough to warrant a dry season?
Well, I guess I can quote what our lead scientist says. If you look at sort of the lowest, so I think like in this case, February and March have the lowest totals. That's still 200 millimeters per month. So it's kind of hard to call that a dry season. So, there are some seasonal patterns that I guess they just tend to call it less wet seasons. But there aren't real distinct seasonal patterns when you look across all the different biotic and abiotic factors. It's not a very strong seasonal trend.
Which is what we see with the box plots and the great amount of overlap between the boxes.
Yeah. Well, let's move to the other group. Somebody from that group like to discuss or share out your discussion and what you came up with?
So we just looked at the mean reservoir height per year. So we had to add an attribute box or column and calculate the mean height per year, which we did, and then we graphed that. And there it is.
Yeah, what we did was we seized on the hierarchical table structure in CODAP by creating the mean from a child case into the parent level case using formula editor in CODAP too. So that was kind of a fun exercise.
So obviously your group also had somebody quite familiar with CODAP.
We had a little help.
So was there a particular question that you had come up with, or you were just still kind of exploring different representations?
I'm not sure we actually had a question. I was just looking at what could be graphed and what could be, that was interesting to me, thinking about if the reservoir is a drinking water reservoir, and Steve had mentioned that there was a drought in 2015, which you can clearly see here. So it just seemed like, something I wanted to view with the data. So we did.
I'm amazed at how quickly the reservoirs recover from those 2 drought years.
Mm-hmm.
That is amazing, yeah.
Tropical climate, you get a lot of rain, right?
Yeah.
So in the Bay Area, we actually have backup reservoirs in case of earthquakes or something like that occurring. Is there something like that going on in Puerto Rico too, or is it just the rain?
I can't really answer that question. I'm not that familiar with how the reservoirs work.
Uh-huh.
So
What do you mean, Beth? Backup reservoirs?
Mm-hmm.
Or I think, sorry, when a reservoir, clearly when the reservoir is built, they take in consideration potential earthquakes because we're also in a very active zone. And I was just asking that question. I went to the Fajardo Reservoir not too long ago because the director is a friend of mine. And I was actually asking him that in case of an earthquake, what happened here? Do you think this is like engineering design for preventing a big catastrophe here? Because it's kind of sit at the top of the mountain, and that water will create a big flood. And they take that into consideration, obviously, when they design this kind of reservoirs there. But I don't know that they call it a backup reservoirs.
Well, of course, also if there's a major hurricane that hits, could also put stress. So, for those that were following the aftermath of Hurricane Maria, there was actually a particular reservoir with a very weak dam, and that created a lot. And I don't know if it ever actually broke or not, but they had to evacuate a big swath of the area along the northern coast because they were afraid that the reservoir was going to break. But there isn't, I think what you mean by as a backup reservoir is during that year of drought, are there other large storages of water? And I think at this point the answer is no. The folks in Puerto Rico are pretty dependent on if it's raining, then there's water. If there's not rain, then there's severe water restrictions. In fact, the rainforest itself provides actually a significant amount of the fresh drinking water in the northeast part of the island. Do you remember what the percentage is, Noelia?
No.
But I think it's more than a fourth and maybe even half of the drinking water for the northeast part of the island. So that's also quite important. But there's no reservoir in the rainforest. It's all about how much flow is coming out of the.
So, Christian, do you just want to ask your question out loud?
My question is if you have used CODAP in your data jams with students and teachers, and if you did, how did you manage the induction period for teachers and students to know how to deal with CODAP, how to learn CODAP to do what we did here?
So this year is really the first year where we really made an intensive, purposeful effort to try to get teachers to adopt the CODAP in lieu of using Excel. So in the workshop that Noelia had mentioned that we just hosted this past January, we devoted, it ended up being about a 3-hour period where what I did with you all just now to sort of introduce how CODAP works and the examples of how to do, looking at scatter plots and looking at distributions of data. That was the introduction that we provided to teachers, and then we gave them time, just like we did with you, to sort of explore the data. We did actually ask them to come up with sort of a more complete mini data jam, and that they actually had to put together a PowerPoint presentation with the data and the question that they had asked. And then you may have remembered the picture of the teachers talking to each other. What they were doing is actually presenting the results of their analyses to each other. So it's basically a one-day workshop where we kind of introduce CODAP, had them explore CODAP, develop a presentation. We also spent some time, as Noelia suggested, looking at past year's data and having them think about what kind of feedback that they would give to their students. So our funding for this is very small, so we don't actually have funding to actually go out and support them or observe what they're doing in the classroom. So we kind of find out the results when they come back to the symposium at the end of May. So that's when we'll see which classrooms actually use CODAP and what the kids did with it, and we'll spend some time interviewing the teachers and kids to find out whether or not they used it and how they used it, and sort of what some of the barriers are to their understanding.
Okay.
Yeah, I can see maybe.
Stephen,
I can see maybe this year, to the fact that some of these schools still have no internet or no power. It might be another restriction for them to be able to use CODAP for the data jam. But we'll wait and see if they actually use it or not when they come with the projects all prepared in May.
Yeah, because I asked the question because for me it's critical to know other experiences. So to answer the question, how much time do teachers or students need to learn basic aspects of CODAP to participate in a jam, a data jam, as we did today?
And it's one thing to become able to participate in a data jam, and yet another thing to feel confident enough to use it with your students.
Yeah. Yes.
Yeah, so I think what we're exploring in this project right now is if we give them kind of a low dose introduction, you know, which teachers actually develop the capacity to actually follow through and use CODAP. And we'll learn from this, and hopefully we'll get our DR K-12 where we can sort of expand the level of support that we're providing for teachers and to be able to do more significant research around that. So maybe we'll present again next year and let you know how it went.
Perfect. Thanks, Steve. Thanks.
So we're out of time, right, Talia?
Yeah, I think we're at time.
All righty. I think I'm going to go ahead and wrap us up. 1 second, please.
I'll have to stop sharing my screen, right?
Yeah, and I'll start sharing. Let me maximize window. Okay. Well, wow, I had a really terrific time. Thank you very much, Stephen and Noelia, for a very engaging webinar. And thank you, everybody, for joining us today. If we did not get to your question, or you'd like to leave additional questions in the Google slide or through dset@concord.org, please do so. We'll leave an answer as soon as we can. We had a lot of great interaction, and I'm grateful for all of you for making such rich discussion and a wonderful data jam. We'll send a link to the recorded session shortly through Eventbrite. If you enjoyed this webinar and you would like to attend future data science education webinars, our next webinar is on April 26th with our own Dan Damulin of the Concord Consortium. Details will follow shortly. You can sign up for future webinars at concord.org/meetup. You can also stay connected with us on Twitter at CODAP Use the hashtag DataSciEd to tweet us any additional questions or resources, and we will respond to you. Please feel free to visit our website, codap.concord.org, to connect with us as well. Thank you all very much, and we will see you on April 26th.
Thank you.
Thank you,
Thank
Talia.
you.
Thank you, Stephen. Thank you, Noelia. Thank you, Bill.
Thank you. Nice to meet you all.
Nice to meet you.
Take care.
Nice to meet you.
Next meeting.
Thank
Bye-bye.
Bye. Bye.